Hello everyone. In this video I am going to show you simple setup with these NRF24 wireless communication modules with Arduino. These modules are very popular because they are very cheap. There are several models of this module, and two most popular are this high power module with external antenna, which costs around $3, and the other one has onboard PCB antenna and goes for about $1 on eBay. In this video, we'll be using this high power module, which has declared range of 1100 meters or 1.1 kilometers. These modules use 2.4 MHz frequency range and can be configured to operate at 125 channels. You can configure them using 4 different power levels from minimum to maximum. Also, they can use 3 different data speed levels: 250 kilobits per second, 1 megabit per second, and 2 megabits per second. For more information about these modules, please check online. Also, there are plenty of tutorials available online for setting these modules in various and more complicated configurations like sensor networks, peer-to-peer communication, or mesh. In this video, I'll be using very simple Arduino sketches, just to give you an idea of how they operate and to test range to see if they really can achieve 1.1 kilometer as declared by specifications. One important thing to highlight is they operate at 3.3 volts. According to specification, the highest voltage these can accept is 3.6 volts. Arduino has 3.3 volt output pin, but when using these high power modules, you will have issues with transmitting or receiving because Arduino cannot deliver power needed for stable operation. One solution is to solder capacitor between voltage input and ground, but much better solution is to use these base modules. Base modules are also cheap, about $1 for a pair on eBay. They have 3.3 volt regulator, so they can accept input voltages from 5 to 12 volts, and when using these, you need to power them from 5 volt output pin from Arduino. This is a nice feature as you can use a variety of input voltages, and the regulator will step down higher voltage to 3.3 volts, so it will be safe to operate NRF24 module and you will not accidentally fry them. Another great feature of base module is that it has set of onboard capacitors, and these capacitors will help stabilize current when transmitting or receiving, and this is mandatory when using high-powered NRF24 modules. Without stable power supply, you will only have issues, so I highly recommend using these base modules. When using simpler version of NRF24 module, the one with onboard PCB antenna, configured to operate at minimum power level, you could power it directly from 3.3 volt output pin on Arduino, but the range you'll get is just a few meters. Now for the setup. This is Arduino Uno, which is already connected to the base module. Here is voltage input and the ground. Voltage input, VCC, is connected to the 5 volts on Arduino, and the ground is connected to the ground on Arduino. Other pins on the base modules are CE pin is connected to the pin 7, CSN pin is connected to the pin 8, SCK pin is connected to pin 13, MO pin is connected to pin 11, and the M1 pin is connected to the pin 12 on Arduino. Our IRQ pin on base module is not connected because it's not needed for our operation. When you want to connect it to Arduino, you just put the NRF24 module to the base module and it should work. Also, the other one, this is the receiving unit. The receiving unit is connected just in the same way as the transmitting unit, and what I added here is a little buzzer, and the buzzer is connected in a way that the plus sign on the buzzer is connected to the pin 2 on Arduino, and the minus is connected to the ground on Arduino. Now we will see the sketches for the receiving and the transmitting unit. Okay, before writing sketches for our transmitter and receiver, we need to install a library we will be using. In this video, we will use NRF24 library by TMR-H20. To install this library, in Arduino IDE, click on Sketch, Include Library, Manage Libraries. In Library Manager, click on Search text box and type RF24. In Filtered List of Libraries, find RF24 library by TMR-H20 and click Install. I already installed this library, but it will only take few seconds for you. By installing this library, you also have many code examples which you can study by clicking on File, Examples, and scrolling down to bottom, you will find RF24 submenu with those examples. Okay, first we will go through transmitting unit sketch. Headers we need to include are spi.h, nrf24lo1.h, and rf24.h. Then we declare rf24 object with name radio, which is connected to pins 7 and 8. Also, we need to set addresses of our NRF24 modules, but since we will not be using bidirectional communication, we only need one address. In setup function, we first start our radio by calling radio.begin method. Then we set the address for our receiver, which we declared earlier. Also, we will set power level of our transmitting unit to maximum. If you recall, there are 4 different power levels you can configure. Since we will be testing maximum range, we will set this to highest power level possible, and this is max. Available power levels are min, low, high, and max. Further on, we will also set data rate to 250 kilobits per second. There are 3 levels of data rate, 250 kilobits per second, 1 and 2 megabits per second. Lowest data rate of 250 kilobits per second combined with maximum power level will give us highest theoretical range possible. As this is transmitting unit, and we won't be used bidirectional communication, we will stop listening functions of the radio by calling stop listening method. Loop function is very simple. We will send array of characters every 2 seconds to our receiving unit. And that's it. Just upload this sketch to transmitting Arduino with NRF24 module and it's ready to go. Code for receiving unit is very similar, with few differences. Again, included header files and declaration of RF24 radio object are the same. Here we need to declare pin at which our buzzer is connected, and that is pin number 2. In setup function, we need to configure our buzzer pin to output mode. Also, the address for reception of data from transmitting unit needs to be the same as in previous sketch, but this time we use open reading pipe method with that same address. Power level and data rate are also the same. Because this is receiver, we need to call start listening method on our radio object. In loop function, we first declare empty array of characters with name text, which will hold our received data. Then we check if data has arrived. If that is true, we will store data in our text variable. Although this step is not really necessary, I declare another variable named transData of type string and cast received data in text array to new string variable. This is to check if data received is the same as it should be, but as NRF24 has error checking embedded, this is not necessary. It's just a precaution. If data received is OK, we will send a tone of 1000 Hz to buzzer on pin 2 for half a second and then stop the buzzer. If you recall, we configured our transmitting sketch to send data every 2 seconds. So while in range, receiving unit will make half-second buzzing sound every 2 seconds, and that will be method of simple field range testing. Okay, so this is our test setup. Now we're gonna power it up to see how it works. This is the sending unit. I'm gonna put it here. So it's working. And this is the receiving unit. And this unit will make a buzzing sound every 2 seconds for half a second. So we got the signal, it's working, and now it's time for the range testing. For testing the range of this setup, I picked up nearly ideal conditions. Straight road with clear line of sight. Receiving and transmitting units were around 1.5 meters above ground. With this setup, I managed to achieve 1070 meters of stable communication between two NRF24 units without data loss. You can get few tens of meters more, but above this line I started to get data loss. At around 1200 meters, no data was coming through, so declared range of high-powered NRF24 module is well within specification.